Hello, everybody. I am Shinobi from Bitcoin Magazine, and I'm joined here by Gloria Zhao, uh, Bitcoin Core maintainer.
Yes, that's me.
We are here today to talk a little bit about mempools, one of the most chaotic, messy pieces of the Bitcoin protocol, which is your area of focus. So I guess to start, you want to kind of just like very high level, like explain like how it functions, like.
Yeah, I think mempool is sometimes underrated as a crucial part of node software that people don't like to think about very much, or kind of trivialize because it's not consensus, but it is kind of a really big part
Mhm.
of things to consider when you're creating transactions and when you're building L2s. And also simultaneously, I think over dramatized sometimes. But the way that I like to say it is mempool is just a cache. We have this distributed network, which allows us to have censorship resistant payments, which is really awesome. And without that, we wouldn't have censorship resistant payments.
Mhm.
But so this distributed network that serves as a kind of obfuscated place for you to broadcast your transactions in a private slash censorship resistant way is an emergent property of individual nodes participating in transaction relay. And my talk yesterday was about how difficult that is
Mhm.
because the individual node software has to be really accessible to run, like on a laptop or on a Raspberry Pi. But what transaction relay is you're exposing yourself to random peers on the network that are going to send you lots of data that you're going to validate, you're going to spend resources like memory and bandwidth and CPU on, but ultimately might not be very useful to you. And unless you're a miner, like you don't get any compensation for this.
Mhm.
And so like that kind of software engineering is really difficult. It's like you have a lot of security problems. But it is what gives us this wonderful payments network that is censorship resistant. So, okay, your question was what is mempool? Mempool stands, it's a shortened form of memory pool. It is
Mhm.
just the pool of unconfirmed transactions. So if you're a miner, you would obviously keep a mempool where you receive transactions from the network, you sort them roughly by fee rate, and you put the ones that are most profitable for you to mine in your blocks, etc.
Mhm.
And then if you are a non-mining node operator, you kind of collect these transactions as they're being broadcast, and you serve as part of the kind of broad transaction relay network. But it's also a way for you to basically slowly validate and download transactions before blocks before they actually become part of the blockchain.
Mhm.
So if you think about like a long time ago, I'd hear these stories of people, they're like on a video chat and you can tell who is running a Bitcoin node because at roughly every 10 minutes on the video chat, their like video goes really blurry
Mhm.
because the block is being downloaded. And maybe like their CPU is spending time like verifying the signatures, which is very expensive computationally.
Mhm.
So to kind of avoid that, you're able to amortize it ahead of time, basically. And that's a really good reason for you to do transaction relay. It also means that you have a pretty, I don't like the word trustless, but trustless fee estimation technique because you see transactions come out ahead of time,
Mhm.
and you can see roughly like when they confirm, you're able to get a better estimate of like what fee rates are going. This is what I mean by trustless here is like it's not as gameable. So if you only relied on block data, you'd only be looking at fees that like miners you're looking at data that's controlled by the miners, right?
Mhm.
And so like, they can have their own zero fee transactions in there. They can kind of stuff their blocks with artificially high fee rate transactions. Like that's what I mean by gameable.
Mhm.
And similarly, if you're relying on, a trusted third party to tell you like what's in mempool, like what are the transactions that you're bidding up against, you're also kind of trusting that those are real transactions. So using fee estimation with your own transaction relay node is very useful. And of course, if you have your own wallet, you're receiving or sending transactions, seeing that come to your mempool is like a pretty good sign that it has been, propagated across the network.
Yeah.
So that's my very long-winded explanation for what mempools
Very,
are.
very thorough, though. Yeah, and so, the way I kind of can conceptualize the mempool is there like these multiple functions that it fulfills. Like, obviously the fee estimation, as you said, um, the ability to kind of protect your node from denial of service, like that's a functionality the mempool has to um, fulfill. But also, I think like the most critical one is response for second layer protocols. Like,
Mm.
obviously they're all designed so that you can respond to things in a block, but being able to see ahead of time what's going on, react to it out of band in the mempool faster, and just kind of have the view of that landscape from the context of I am engaged in this layer 2 protocol and I actually need for the security of my money to know things like the fee rate, like was this transaction broadcast, do I have to react to this now? And like that, I think, is the most critical reason why it's so important to maintain a public mempool, because we are pretty much betting everything on Bitcoin's long-term success in layering out these second layer protocols. And if we don't have that public mempool, if we kind of devolve back to these centralized APIs or just trusting what miners put in blocks, like the entire landscape of those security assumptions just shifts out from under us.
Yeah. Like the talk, Neha's talk that we were just at before
Mhm.
this, where she's talking about L2s and scaling in general. She's like, all of the, like, what makes L2s is this idea of unilateral exit. And we can no longer treat it as just given that, like, oh, as long as the user is able to get the transaction confirmed, then they can unilaterally exit and get their money even if they're being attacked. It's like,
Mhm.
well, the part where they're able to get their transaction confirmed, like you said, relies on like being able to get your transaction to miners, sometimes in competition with your counterparty's transaction, where the spending path goes to them instead of you,
Mhm.
and usually in like a really like constrained time scale. Like there's some kind of time lock where like after this point they can take the money, or before
Mhm.
this point you have to respond. And like I think in the past few years we've seen like very wildly fluctuating free markets. Yeah, so like I think it is a really, I've been saying this for a long time, like it's a very important part that is underrated in like L2 security models.
Mhm.
Yeah, so I've spent a lot of time on pinning attacks, which is like I just alluded to, where the counterparty deliberately tries to take advantage of mempool limitations because of kind of um, uh, poor heuristics or bad logic or bad algorithms for how we assess transactions, and at least Bitcoin Core's mempool logic, to kind of stop it from propagating or stop it from being mined. And so like a lot of the work that like package, for example, package relay or like the truck things and even cluster mempool are about optimizing how we assess the incentive compatibility of transactions. Like how do we tell what the fee rate is basically?
Mhm.
And this is like within the context of like, all of the transactions it depends on, or like it may or may not replace. And there's lots of places where this breaks down, and it's like if you run, for example, Suhas did research on all the 2023 mempool transactions, and if you do it through cluster mempool and those logic, the very few transactions are impacted, and the fee difference is like less than 1%. And so people will be like, well, what's the point of this? Um, First of all, as we said, in like layer twos, this can be a security concern. And also, like, it is really important as the subsidy decreases that these fee optimization kind of things are publicly available and are
Mhm.
applied in the public decentralized marketplace, because the reason why centralized marketplaces might exist, like miners essentially being like, hey, you can pay me a little extra for me to mine your transaction, is if the public one is inefficient.
Mhm.
And you can totally understand why a centralized marketplace would be more efficient than a decentralized one. But if there is room for a private miner to like spend some extra money on a researcher or an engineer to optimize their mining template or like do some kind of Meevil kind of stuff, that's really bad. It creates centralization pressure,
Hmm.
and is ultimately very toxic for the Bitcoin network.
Yeah, I mean, it's really a kind of an existential issue in my mind, and I feel like the whole ordinal saga, over the last year and a half or so, is kind of the perfect demonstration of that. This use case, if you want to be charitable and call it that, that was very unpopular with a lot of people. It had real economic demand for it. And a lot of the transaction structures that they wanted to engage in, for the larger inscriptions and silly things they were doing, it violated mempool relay policy.
Yeah.
So like that kind of demonstrated like this is a real concern of economic incentives driving users to go directly to miner submission and bypass the public mempool just because like they can make money if they do so.
Yeah.
And so like, what do you think about how to kind of approach that in the long term in balancing policy restrictions versus like these use cases that, you can be pretty sure most of them will be unpopular, but do have real economic demand behind them?
Yeah, yeah. With all the ordinal stuff, I was like really regretting being the mempool maintainer because people would yell at me where they're like, you need to add policies to ban inscriptions. And then there would be people who were saying, you need to relax the policies that like create these incentives for people to submit non-standard transactions to miners. And like my kind of generic response was always like, the policy rules exist for like pretty specific technical reasons. Like we need to be DOS resistant. We can't just relax like SIGOP related rules or like the max standard size rule. Like they exist for really good reasons for to make it accessible to run a node. Like but I agree with people that it should be minimal, right? Because you don't want to create these incentives. But like I have a blog post, but like reasons like preserving upgrade hooks, like the banning of 64 byte transactions, which really should be a consensus rule.
Yeah.
Shout out to the consensus cleanup. That like they're real security concerns. So it doesn't really make sense. Like weighing that against like, but somebody might want it. I think it makes sense to keep policy rules like that. But I do generally agree that like it shouldn't be so cumbersome for bad reasons that when people have good use cases, they're forced to go through centralized pools. I think I fully agree with that. And then like the other thing that I was saying to people is like policy is for like when we're assessing if a transaction is bad, it's like network resources. Like, for example, we don't like dust because that presents a long-term cost for every single node runner to have lots of tiny UTXOs in the chain state. It's not assessing good or bad on the basis of use case. And I don't think it's like protocol development's place to be like, this kind of transaction is bad based on use case, because that's kind of like against what Bitcoin is all about.
Yeah.
Yeah.
If you're making those decisions, then that's not a very open access, censorship resistant network.
Yeah, yeah. But I understand, like, there were so many arguments where I was like, yeah, like, it's a hard topic to talk about. That's my 2 cents.
Yeah, I don't envy your position. You want to talk a little bit about V3 truck transactions and package relay? I think the work you and Greg have done on that is massively important for layer twos. Like that's a whole class of problems and security concerns that is now very constrained in a nice, easy to reason about box.
Yeah, thank you. Yeah, so I think the way that I approach this is like from a very like problem solving kind of perspective. And I picked up package relay maybe like less than a year into working on core, and it was like the biggest can of worms ever. He was like, oh, like just, send multiple transactions. And so I picked it because it seemed to be like a completely uncontroversial, like pre-concept act project that everybody seemed to agree, like we have to do package relay at some point. So I didn't I think that's good for beginners because like as a beginner, you don't really know what's a good idea. Um, but like if there's work to be done and code to be written, like and tests to be written, like of course you can do that as a beginner. Like you can ramp up to do that.
Hmm.
But it's really bad to like start with an idea that requires you to argue with people, right? So yeah, the general idea is kind of what I summarized earlier, that I realized package relay is really about is not just sending multiple transactions, right? It's about fee bumping inefficiency. So like if the classic problem is once minimum fee rates rise, you can't CPFP your transaction because
Hmm.
it needs to get in by itself and then be CPFP'd. So that's kind of the whole point of package relay. But really this general problem of like you can't bid for block space because the mempool logic is not smart enough to understand that your package is actually really high fee rate.
Hmm.
It's just for this like technical limitation reason that it isn't able to do this. And so we discovered lots of limitations in this category where it's like, oh, sometimes you can't RBF your transaction because the RBF logic only looks at this and blah, blah, blah. And we discovered it's like a really hard problem because transactions can have dependencies, packages can be all kinds of topologies that make it really, really difficult to assess.
Hmm.
And so that's part of, I would say this is part of the reason why cluster mempool came about, where cluster mempool is like the complete solution to like generic, like all topology, not all, but like kind of more general, better fee rate assessment,
Hmm.
essentially. And it requires basically a total rewrite of mempool and how we track transactions, but it's so worth it. And so that's kind of in the works, and then general package relay will come later. But we've added like a limited version where it should be enough for all basic L2s, or at least L2s get kind of all the features that you want, but or most of the features that you want in the topology that is minimal. Whereas basically like truck stands for topologically restricted until confirmation. It's basically we can do all of this perfectly if you only have one parent and one child,
Hmm.
because we don't hit all of the cases where this gets more complex. So we've added the logic to do that, and it was comparatively way simpler. It's still a lot of code, and it took a long time, but it's comparatively simpler. And then, so like, there's actually like usage. Like I met people who are like, hey, I'm using truck. Like, can I do this? Can I do that? And I'm like, whoa. And they're like, yeah, like the Bitcoin Core wallet doesn't support it. And I was like, oh yeah, we didn't even get to that yet. Why are you like, you're already using it?
Hmm.
So it's like way more popular than I expected, which is amazing. It's a great thing. Like, you know, Lightning has like their build proposals and stuff. I'm like, wow, like this has happened really quickly. While we work on the more general solution. And Peter and Suhas, like they're the ones who were like, okay, let's like we killed Batman, you know, like they're like like cluster mempool is such a hard problem. And like the reason why I went after truck was I was like, okay, it's a really hard problem. We can avoid it by just having like simple topologies. And honestly, like if it works for 90% of use cases and it's like way simpler compared to cluster mempool, which I was like, I cannot imagine working on this.
Hmm.
Like I thought it was a really good idea, but like very, very luckily they have taken on the Herculean like feat of
Hmm.
completely rewriting mempool to do this.
I mean, it's a totally logical path to me. Like if you can get 90% of the way there with 10% of the work and then kind of let the the other wizards handle.
Yeah. Yeah. I mean, yeah, like it takes a village to do everything. Like
Hmm.
yeah, I think it's lucky and I think a sign that we're doing something important, that there are people who have kind of rallied behind this general problem of I call it like efficiency of the transaction relay, efficiency of the block space marketplace,
Hmm.
basically.
And I guess you want to kind of, at least at a high level, just break down like where kind of truck and minimal package relay jumps to cluster mempool? Like how does that functionality like kind of build on what you've done, and how does that function in general?
So from a user's perspective, what you can now do is you can have a zero fee transaction. You put version 3 on it. Um, and as long as you have a child that is fee bumping it, it basically kind of gets to be, it's treated as one transaction. Or we have full package support basically for this very basic topology, so much so that like the parent can be zero fee. It can even have an anchor, an output that is spent by the child that has zero value in it, which is awesome because it means that contracting protocols can pre-sign transactions with their counterparties, not really need to negotiate what those fees are going to be because you can add them later. You can have just one anchor, which is keyless that either of you can spend instead of having two, and it can have zero value in it, so you don't need to like shave off channel balance into these outputs. So if you were to have like an Ellen symmetry kind of style thing where you can have a lot of update transactions, you aren't like shaving off outputs at each step. That's really powerful. And this is not just for like for Lightning. If any kind of shared UTXO thing, coin joins, for example, which are not Lightning, where you have a lot of different participants in the transaction. You can just have one anchor. So if anybody wants to bump it later on, you're not all kind of stuck competing with each other. You can just replace that anchor and anybody can spend it. And that's awesome. And you can submit that to your node. It will propagate mostly. It will propagate in the happy case. So I've tried to be really, really loud about this, that it's not reliable. It uses kind of an opportunistic part of the transaction relay logic, essentially. But this meant we could do it without a protocol change. We were able to do it without even changing the amount of bandwidth that would be used for relaying these transactions. So these are all kind of really minimally invasive and just, magical kind of things. These packages, one parent, one child packages, can also replace each other. So like commitment transactions where you have two, for Lightning, like the parent, which is the commitment transaction, and its child can replace another commitment transaction and its child, even though the two parents spend the same. That was kind of complicated to figure out, just saying. But we have that functionality. So because we're able to do that, you don't need two anchors and you don't need CPFP carve out. And CPFP carve out was like the last thing that we had to figure out how to remove in order to do cluster mempool. And so kind of they have this symbiotic relationship, essentially, this like truck package relay thing where cluster mempool is enabled by the fact that this 1P1C package relay stuff negates the need to create things that require CPFP carve out. So we can have cluster mempool, and then cluster mempool makes the mempool logic so much better, so that we can actually build more generic package relay on top of it. So they all kind of mesh really nicely together, and together they solve this like really important class of problems.
I think it was Francis Pouillet who said the mempool is a war zone.
Yeah, I think I gave a talk at BTC++ like 2-3 years ago called Mempool as a Battleground, and it was about pinning. Yeah. I don't know exactly what war zone that is referring to, but yes, in many ways, it's a contentious place. Yeah.
So it's really like a kind of a whole roadmap. We're like halfway through right now, pretty much.
Yeah, it's exciting, and then we can work on some other things. Yeah.
I'm biting my tongue to not make the joke.
What joke?
When next soft fork?
Well, so like I felt like this was more. So I think there's maybe the elephant that people say in the room is like a lot of people in Bitcoin Core seem to work on things that are not soft forks, even though a lot of the community says this when next soft fork.
Hmm.
And hopefully, based on what I just said, it kind of makes sense why I would focus on this particular thing. There are a lot of interesting and important problems within core. A lot of times when I was looking at, I think there's this vault paper or like a lot of the covenant kind of things that were about L2 scaling, I was like, well, but what about like the unilateral exit problem where you could get pinned and not be able to confirm your
Yeah,
transaction?
it's like all of those design spaces depend on the problem that you and Greg fixed being fixed to be viable ideas in the first place.
Yeah, yeah. So it's like, yeah, we all care about scaling. Like we're on the same team. We're focused on different parts of it.
Hmm.
And not to say that the fee bumping problem is the most important part, but I felt like it was really under served
Hmm.
in terms of development attention. So yeah, I think me personally not working on the covenant stuff. Well, I try to follow along, but like it's not because I don't care about scaling. It's
Hmm.
because working on a different part of the elephant.
Well, I mean, it's, work on the mempool is just as important as the consensus layer. Like this,
Thank you
this
for saying
entire
that. I needed to hear that.
like this entire like protocol stack has to scale, and you can't just focus on one area of it and make changes or alterations and then not take into account like how that's going to alter the functionality of something else that you left alone. Like it's a dynamic system. When you start changing pieces of it, that's going to have consequences that ripple over to other places,
Yeah,
and you really do have to step back and kind of take a holistic view and approach, or you're going to wind up breaking things.
exactly. Yeah. We'll all get there together.
Hmm.
Yeah. And like I don't speak on behalf of anyone else in core, but like there are a lot of other things that other people work on that are not soft works that are also really important.
I mean, the kernel project, like just so that we can pretty much pull the consensus logic out, and if people think that what you and Greg did is not the best way to handle things, they can go off and do something else, but still have like a stable consensus library they know will stay in sync with core and
Yeah.
not break and fork off onto its own chain.
Yeah. Yeah. And I think so many people in core being so supportive of kernel, both in their time and like in their words, is also like obvious evidence that like the people that work on core also aren't trying to be the incumbent like only consensus implementation.
Hmm.
Because the whole point or one of the reasons for kernel that I see is like it would be great for there to be not 98, 99% Bitcoin core. It's very stressful
Yeah.
for the whole network to need for this, right? But like at the same time, what I think is probably what is more important than having diversity of clients is that all the clients have the same consensus.
Yeah, it's,
Staying in consensus is pretty important.
kind of the key thing.
Yeah. And I think we've learned over and over again that like trying to re-implement consensus from scratch just does not work.
Yeah, I
Yeah.
kind of feel at this point like consensus bugs with BTCD is like Kenny getting killed in South Park. It just happens every episode.
Because it's so hard, right? Yeah.
Mhm.
I have a call at Brink. I worked a lot with Nicholas, who does fuzzing and differential fuzzing of different implementations, and yeah, it's it's not trying to dunk on people for writing alternative clients. It's just really hard, and it's
Mhm.
fuzzing just finds consensus bugs left and right. Yeah.
Well, I guess you have any other things you wanted to touch on or any final comments you wanted to make?
Yeah. So I'm going to shill test. Well, I don't know when this is coming out, but test the 29 release candidates, please. In general, please test release candidates. And in general, try to at least upgrade to minor releases because they have security fixes and patches. We talked a lot about like 1P1C and truck and soon to come ephemeral dust. Those things only work on the network if there are nodes running them. And as far as I know, like don't quote me on this, but it's been 6 months since 28 came out, and I think only one miner is actually mining V3 transactions, something like that.
Sounds about right.
Yeah. So, I mean, I'm not trying to like force people to like run different nodes, but, you know, at least keep up with the miner release updates because they have security fixes in them.
And I guess, you know, before we sign off, I'd like to apologize on behalf of all of the retards in this space for the stupid shit you have to put up with.
Thank you. I appreciate it.
So thank you for sitting down with me.
Thanks for having me.